Nice. We're doing inverse trig derivatives today. So we're 181, Tuesday, Thursday, week 5, class 2. And we're working on section 3.6. We did 3.5 on Tuesday. Make sure you're doing some work. Ask me for help, right? Look at the implicit differentiation problems on old tests, right? Make sure you can do those. I like you working in this section because it starts easy and then gets more difficult, right? So anyway, we're looking today at y equals arctan of x. This is the inverse function of the tangent function. So you did all of this inverse trig work in pre-calculus. If you did not, some reason your teacher skipped it or you haven't taken pre-cal, you have to know these functions, okay? So I think I had told you on Tuesday, read up to example 4, and that's a nice little introduction to those inverse trig functions again. So make sure you do that. If we graph this particular function, it looks an awful lot like which function? You recognize it? It looks an awful lot like the tangent function. Right? And what happens with inverse functions, we switch our domain and range, right? So you can already tell that this has got horizontal tangents, asymptotes, horizontal asymptotes at what heights? Pi over 2, and yeah, plus or minus pi over 2, right? Because the domain and range are switched with the inverse trigs and the trigs, right? And we also know that inverse functions are reflections about what line? Inverse trigs are reflections about what line? Y equals x. Y equals x. So a reflection about the line y equals x actually we'll rotate it once and then flip it around. So we'll rotate, right, and then flip. So do you see that has happened to my tangent function? You see it rotated this way? Yes? And then flipped upside down, and that's what I get. Better yet, sorry, rotate here, right? Do you see that now you can see it, and then flip. Do you see it? Rotate, flip. That's how we figure out an inverse function, a reflection about the line y equals x. So what we want is the derivative of the arctan, what we're trying to figure this out, right? So, but we don't know what to do, but I do know how to take a derivative of a tangent function. So what I'm going to do is take the inverse trig of both sides, right? So starting with y equals arctan of x, I'm going to take the tangent of y, and that should equal the tangent of the arctan of x. And what happens on the right-hand side? What do tangent and arctangent do to each other? They cancel each other out. They're inverse functions. So I end up getting tangent of y is simply equal to x. And what did I tell you Tuesday? If I give you a trig, that means you have a right triangle. If I give you a trig, you have a right triangle. And so I have a right triangle with an angle of y, and what does my tangent function give me? Which side is x? Opposite. Adjacent is 1. And just like the other day, we figured out the remaining side by Pythagorean theorem. We got square root of 1 plus x squared. now I don't know if I need the triangle. So, but in general, if you have a trig, you have a right triangle. Make it. If you don't make it at first, make it later because you might need it, right? In this case, we need it. So I want to do the derivative with respect to x of tan of y, and that should be equal to the derivative with respect to x of x. On the left-hand side, we need a chain rule with implicit differentiation, what we did Tuesday. So what's the derivative of my outside function? Secant squared. So secant squared of y times what? Y prime equals the derivative of x, which is 1. Remember, I'm solving for y prime, right? So I know y prime is 1 over secant squared y, which might as well just be cos squared y. Agreed? 1 over secant is cos. Yeah? And from the triangle, what do I get? What's my ratio for cosine? Yep, 1 over, so adjacent over hypotenuse, right? So 1 over square root of 1 plus x squared, quantity squared, right? Because it's cos squared. So final answer is 1 over 1 plus x squared. There's my derivative of the arctan of x. Now, what's weird is when you're doing derivatives of arctan, you don't have to do this implicit thing. You just have to put things into our formula. So I want to rewrite it another way. I want to write it two ways, and I probably will put both on my formula sheet. The first one is if y equals arctan of x, we know now that y prime is 1 over 1 plus x squared. And I want to always now have a chain rule version. So y equals the arctan of u gives me y prime is 1 over 1 plus u squared times the u prime. Notice what u prime is in my first version of it. What is u in my first version? It's x. And what's the derivative of x? 1. So you see my u prime is just the derivative of x, right? So we kind of want both these versions on our formula sheet. And of course, it's the second one that we are more concerned with. If we do that one, if we have that one down, we have everything we need. The first one only works if the inside is x, right? So let's do like one of my favorite problems here. Let's do y equals arctan of x squared, and let's find y prime and y double prime. So arctan of x squared is this guy. Remember, whenever you get a function that you don't recognize, you should graph it, right? Graph every function. You can kind of see where my first derivative will be 0. Do you agree? Where's my first derivative going to be 0? Right? Do you agree? And you can kind of see where my second derivative will be 0. These little turning points when I'm turning the wheel of my car. Right? Good. We want to do d dx of y should be the same as d dx of arctan of x squared. Now, when I do this, I want to kind of have my little formula ready, right? I know that y equals arctan of u gives me y prime is u prime over 1 plus u squared. And you'll see that me doing this derivative is quite different than doing the derivatives in the past. Because what do I need for my derivative? I need u, right? I need u. I need u squared. I need u prime. Yes, you see it? I need u, because how the hell do I find u squared if I don't have u? And I need u prime, right? So all I'm going to do is identify u as got to be x squared, correct? U squared is what? X to the what? Fourth. And U prime is 2x. Agreed? So now I'm just plugging in. So this makes these inverse trig derivatives quite different. All I have to do is plug in, right? So from my purple box here, I get y prime is what? 2x over 1 plus x to the fourth. Done. It's that simple. I use the implicit differentiation with the inverse function to figure out the derivative. And now once I have the derivative, all I have to do is plug into that pattern. And it's going to be the same every time. Find u squared, find u prime. And then the algebra is going to suck after that, of course. Not in this case, not too much anyway. Well, there's my first derivative. Are we okay? When is that equal to 0? At 0. And that's where we said we have a horizontal tangent at 0 on the original graph. Is the downstairs ever equal to 0? No. So I don't have a critical from the downstairs. When I have a critical from the upstairs, I could have a horizontal tangent. When I have a critical from the downstairs, I'd have a vertical tangent, right? Like y equals square root of x, right? And what's the derivative? 1 over 2 square roots of x. What makes the downstairs 0 there? Duh. 0. So if I'm skiing on this hill, right? When I finally get to 0, I do a face plant, right? My skis are straight up in the air, vertical tangent. When the numerator is 0, I get a horizontal tangent. When the denominator is 0, I get a vertical tangent. Let's do y double prime. So I need a quotient loop. Yep. And my first upstairs function is 2x. What's the derivative? Good. The downstairs function is 1 plus x to the fourth. What's the derivative? 4x cubed. Beautiful. Is everybody there with me there? 4x cubed. The derivative of 1 is 0. Derivative of x to the fourth, bring down to 4, reduce the power by 1. I need to be thinking about that downstairs squared. And I get my quotient loop. I get 2 times 1 plus x to the fourth minus, 8x to the fourth? Is that right? Yeah. Over 1 plus x to the fourth quantity squared. Second derivative. I want to work on that upstairs. What do I get? I get 2 plus 2x to the fourth minus 8x to the fourth all over 1 plus x to the fourth quantity squared. So what do I get? 2 minus 6x to the fourth. If I factor out another 2, I get 1 minus 3x to the fourth. It's not pretty, but it's all right. And where do you see my criticals at here? So on the bottom can't be 0, right? Right, 1 plus x to the fourth is like that, right? Never 0. Upstairs, so I have a 1 minus 3x to the fourth equals 0. So x to the fourth equals what? 1/3. So x squared is plus or minus 1 over the square root of 3. And so x is plus or minus square root of 1 over square root of 3. And that's where I'm seeing those 2 red dots. Minus square root of 1 over square root of 3 plus square root of 1 over square root of 3. And I guess we can make that look a little bit nicer, couldn't we? Any ideas? Yes, so the outside root is a half, right? And the inside root is a half, right? So we have fourth root of 1 over 3, right? Doesn't look that much better, but anyway. Nice. Let's take a look at the book. So we're looking at chapter 3. We've done chain rule 3-4, implicit we did Tuesday. We're doing inverse trig functions and their derivatives, so 3.6 exercises. Uh, 17 is a nice one to do. What's the inside function? Arctan or inverse tan, right? They're same thing, same different notation, same thing. I like to write arctan because students get confused with that -1 power. So I'm definitely going to need 2 times the arctan, right? Do you see 2 times the arctan there? And then times the derivative of the arctan. Do you see it? 1 over 1 plus x squared. You see it or no? We got 1, 2. People say yes. Again, bring down the 2, right? So there it is, 2 times arctan now, times the derivative of arctan, the derivative of the inside, which is 1 over 1 plus x squared. Look at 18, that's the problem I just did, but only with the first derivative they wanted, right? Let's do 23. This one's quite hideous. So I have to take a picture so I don't forget it. Might as well take a picture of the answer too. So this is 3.6, number 23. I've got y equals the arctan of x minus square roots of 1 plus x squared. And again, inverse tan or arctan are the same thing, right? The book has it as inverse tan. But I don't like using that notation, but they mean the same thing, okay? On your calculator, it's written this way. On your calculator, it's this function. Nice. What's our memorized little formula? If y equals the arctan of u, y prime is u prime over 1 plus u squared. It is that simple. That's all you need to know. And then what's your game? What's the game? Do you remember? Find u squared, find u prime. Then do the algebra. So u is x minus square root of 1 plus x squared. U squared is that squared, but I'm not going to do it yet because I'm afraid if I don't have to do it, I don't want to do it, right? I'd have to FOIL everything out there, yes? And then I also need u prime, which is what? 1. I'm doing the derivative of this, right? So derivative of x is 1, agreed? Derivative of a negative is going to stay negative. Derivative of a square root is 1 over 2 square roots. What should stay inside? Nice, 1 plus x squared. And then I need the derivative of the inside, which is 2x. Beautiful. Nice. So I get 1 minus x over square roots of 1 plus x squared. And I don't know if I really want to do anything else with that yet. Remember my theme was, do I have more than one fraction here? Yes. So when that's the case, you want to get only one fraction, but let me wait. Okay, just let me wait and see what happens. All right, now I'm plugging in. So y prime, I need, right, from my purple box here, I need u prime, so I need this upstairs over 1 plus u squared. So 1 plus x minus square root of 1 plus x squared quantity squared. It looks like I have no choice. It looks like I have no choice. I'm going to have to FOIL that out. You see what I'm saying? I mean, look at the answer again, right? Look at the answer again. What? Right? So look, we've done everything right so far, and this is going to happen several times in chapter 3. Sometimes in chapter 4. You're going to have the answer right, but it's going to be different in the book. That means you need to do some algebra. Okay? Be patient. Don't give up. It's okay to make mistakes. Try again, right? I used to say in trig, if you first don't succeed, triangle again, right? So it looks like I have no choice but to FOIL that downstairs out. So I'm just doing FOIL in my head there, right? But again, you're going to copy your notes over later. Don't skip steps, right? Make sure if you need to FOIL it out with arrows or whatever, or on the side, you do that, right? You know what I'm saying? I'm saying like over on the side, x minus square root of 1 plus x squared is x minus square root of 1 plus x squared times another one, right? You know what I'm saying? And then your x times x is x squared, right? I get a negative, oh, I made a mistake there, right? That should be negative 2x square roots of 1 plus x squared. And then the last term is a negative times a negative, which is a positive. Damn, good thing I did that. Don't the two things in your head. It's scary in there, for me at least, right? It might also be for you. Well, it looks like I can combine some things downstairs. Do you see that? Do you see anything that can be combined? It looks like there's a 1 plus 1, and there's an x squared plus x squared, right? So I have 2 plus 2x squared minus 2x times square root of 1 plus x squared. And so now I'm going, hey, you have fractions within fractions. So let's clear them, right? So what would clear fractions for me? Beautiful. Square root of 1 plus x squared all over itself, right? We're going to clear out our fractions. So in the first one, I'm just going to get square root of 1 plus x squared minus x. And on the second one, it's pretty nasty, isn't it? It looks like 2 plus 2x squared times square root of 1 plus x squared, and then minus 2x times a 1 plus x squared. I probably should have gone a different way with this. Did you see an easier process for this? Not really, right? Because I'm thinking now I need a conjugate. So you're talking about in my last line? Yes, I did. I took it out of the root, right? And then I combined it with this. It's just looking horrible. Look at that answer again. So I'm gonna stop doing this. I'll work on it later and try and get it right, but you should keep working on it. I think I need a conjugate. I think I need a conjugate. Oh, I see something. I see something. I can put this 2 in here. Let me see if that does anything for me. I think I need a conjugate upstairs, but I don't feel like doing it yet. And this is part of the game. I gotta play around with this algebra. You see now I can factor something out of that downstairs. Oh, look at that. Look at that. I didn't need a conjugate. So those cancel, right? And there's my answer. Now, of course, I could factor out that 2, but it really doesn't do much for me, right? Factoring out a constant never changes critical values. Ooh, tough, horrible. Get used to it. Get over it. Practice. Yes. Yeah, you don't want to. You don't care about copying it. You want to do it over. Yeah. You don't. So you don't care about copying it. You'd rather do it over yourself, right? Does that make sense? You don't want to just be copying me. You want to be doing these problems on your own. Make mistakes. Ask for help, right? So when you get stuck on something, you want to send me a picture of the problem. You want to send me a picture of your work. You want to add some comment like, not sure how I can get the answer in the book. And I'll say, oh, you got to factor upstairs or something. Stay there. I probably could have gone a little bit quicker. Not fast, but maybe a couple less steps if I had seen it. But again, it's like you're a musician. You know the notes, go play a song. When you first play a song, it doesn't have much feel. You got to get some soul to it. You know what I mean? So that's the same thing you're doing with your math. Oh, you got to do some algebra here. Okay, do the algebra. It might be pretty clunky or rough or annoying. Tough. Get over it. Get in there and do some work. Cool. There are 2 more inverse trig derivatives that I want you to have on your formula sheet. I only use the 3. In fact, I probably only use 2. Arctan, arcsine, arccosine. So we want to write those down. These are our inverse trig derivatives. In Calc 2, you might use the arc cosine or arc secant or arc cotangent, but I restricted just the inverse tan, inverse sine, inverse cosine. So y equals the arctan of u gave us y prime is u prime over 1 plus u squared. If y equals the arcsine of u, just memorized y prime is u prime over square roots of 1 minus u squared. And the last one, if y equals arc cosine of u, y prime is the opposite of what I just got for arc sine. So you can see I don't really need the arc cosine. I could just call it the opposite of arc sine, right? Nice. So the problems in the book I like. The problems in the book I like are from probably up to 43. Now let's say up to 30, 39. Do problems in the book for up to number 39. Do the odds because you have the answers, right? Do one problem, look at the answer, see if you got it right. Yes? Ask for help. Don't waste time. I used to work at school on homework because if I went home, there were two boxes that were quite distracting. One was a TV and the other had cold beer inside. And then I worked with my study group most of the time, and we would meet at the Math Learning Center. And so if we had a question, we could ask someone who was working that day. Or I could go over to my professor's office and ask. Yes. Okay, I'm worried. Let's get some work done. I'll stick around a little bit if you want to talk to me. Otherwise, have a great weekend, safe weekend, lots of practice. Min, give me 1 second here, okay? Just because I don't want to record.